Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about some of the model performance indices for a classification model. Typically, I'll be talking about what's a confusion matrix, what is the precision value, recall, and F1 score. Even before I talk about these model performance indices, may I request you to subscribe to my channel, also like and share my videos. For this video, I've taken a fictitious data set. I have got 4 columns, namely serial number, name of the person, his actual category, and the predicted category. If you look at the first instance, his name is John. He's been a criminal in the past, and the judge also has predicted him to be a criminal. Let us suppose, for the sake of this discussion, we want to assess the performance of the judge. We want to see whether the judge is really good in classifying an individual as a criminal or as an innocent person. With this intention, we have 2 columns, actual and predicted. The actual categories are not shown to the judge. The judge is basically expected to classify an individual as an innocent person or as guilty based on the credentials of these individuals. So coming back to the first person, John is actually a criminal and the judge has classified him as a criminal. Let's look at the second person, Shalini. She is an innocent person, but the judge has misclassified this particular individual as a criminal. The third person, his name is Matthew. He is a criminal. The judge has got this person, this particular case right, because he is predicting the case as a criminal. Now, at an overall level, if you want to assess the performance of this particular judge, we can't manually look at each and every individual. We would like to consolidate the results and tell what is the overall performance of the judge. If most of the predictions are right, we can go ahead and say, yes, the judge is very competent. The judge is doing a fantastic job of identifying a criminal. On the other hand, if the performance of the judge is less than, let's say, 70%, we can say that, yes, the judge is not doing such a good job. Now, to understand this, we need to compare 2 important columns, namely the actual and the predicted. Let's get a feel of the quality of the predictions that have been made by the judge. I'll just be applying a filter. As you can see here, we have the actual category. Let me apply a filter and select only the criminals. When it comes to the predictions made by the judge, I'll be applying a filter here and select only the criminals. As you can see here, these are the 4 individuals, John, Matthew, Abdul, and Andrew. Their actual category matches the predicted category because each of these individuals are actually criminals and the judge also has pronounced them as criminals. So there are 4 individuals whom the judge has correctly classified. Let's look at another category wherein the judge has got it wrong. Under the predicted column, I'll apply the filter, but this time, instead of choosing criminals, I will be choosing the innocent people. Please understand, here, their actual category is that they are criminals, but the judge has misclassified them as innocent people. You can clearly see here, in the case of 2 individuals, namely Geeta and Saurav, both of these are criminals, but the judge is predicting them as an innocent person. This clearly is a misclassification. When the actual does not meet the, when the actual category does not match the predicted category, that represents, that indicates a misclassification. On the other hand, when the actual category matches the predicted category, that indicates correct classification. So we've seen 2 cases wherein, in the first case, wherein the actual matched the predicted category, and the second case wherein the actual did not match the predicted category. Let's now move on to the third case. Here, under the actual column, let me apply the filter. Instead of choosing criminals, let me now select innocent people and hit the OK button. You can now see here, there are three individuals, namely Rita, let's say Bashir and Sandra. These three individuals are innocent people, and the judge is also calling them as innocent people. Here again, you can see the actual is matching the predicted category. When the actual matches the predicted category as before, we can go ahead and give a thumbs up to the judge, because the judge here has got it absolutely right. These individuals who are innocent have been correctly pronounced in the judgment as innocent. Now, let me apply the filter for the predicted category. Instead of choosing the innocent category, I'll choose the predicted category as criminal. Let me hit OK. You can see here, there is one instance wherein the judge has got it wrong. In the case of a person called Shalini, her actual category is innocent. She's an innocent individual, but the judge has misclassified this person as a criminal. So we've seen 4 cases of how the actual is compared with the predicted category. Let me now remove the filter. Now I know that this is a very small data set. If you have, let's say, 10,000 records, it becomes a bit difficult for us to apply a filter and manually look at each category. So what is the way out? For the sake of simplicity, what I'm going to do is I'm going to create a pivot table, and using the pivot table, we can go ahead and construct a confusion matrix. To construct the confusion matrix, let me select the range. Once I select this particular data set, I can go to the insert menu. The very first option that you see here is the pivot table. I can choose the option from table. Pivot table range has been selected. Now I'll go ahead and click on the OK button. You can see here, these are the pivot table settings. What I would like to do now is, I've got the actual category. Let me drag this and drop it along the rows. I've got the predicted category, which I will be using along the columns. There is a column called a serial number, which I will use under the values option. By default, Excel is going to add the serial number. I don't want to add the cases. I simply want to take the count of the cases. And therefore, instead of sum, I'm going to choose the option count. Let me close the pivot table field settings. What you have is a simple 2x2 matrix. Along the row, you have the actual category, which is being broken down as criminals and innocent people. And along the column, again, you have 2 categories, namely criminals and innocent people. Now, what I like to do is, I like to copy and paste this particular pivot table in a separate Excel sheet. I've already done this for you. You can see here, this is the confusion matrix. So this is the output which you are seeing as part of the pivot table. Let me again go to sheet 7. You can see whether the numbers match 4, 2, 1, and 3. In the confusion matrix, I've got the same numbers 4, 2, 1, and 3. The only difference is that I've actually given it more meaningful labels. Now, this kind of a matrix is called as a confusion matrix. And we are going to pull out certain important metrics which helps us assess the performance of the judge. Even before we go ahead with some of these metrics, we'll have to answer a simple question. Between these 2 categories of people, namely the criminals and innocent people, which category would you call as the positive category and which category would you call as the negative category? For all practical purposes, when you talk about criminals, I would like to call them as the positive category. It is not that every day you will be seeing a criminal. Let's say you meet 100 people, 98 of them are likely to be innocent people, good people. You may find 2 of them who are criminals. So the definition of a positive category is that the positive category indicates that specific category which is of interest to the researcher or data scientist. Whichever category is relevant to your study, whichever category is of interest to you, that category you can go ahead and call as the positive category. The other category will naturally be the negative category. So here, between the criminals and innocent people, I'm going to call the criminal as a positive category. I'm just going to indicate this with a plus sign within the parenthesis. And as far as the innocent people are concerned, I'm going to call them as negative people. Again, criminal will be positive and innocent would be negative. Let me just take a moment here. Suppose you're building a fraud model tomorrow. In that case, you may have 2 distinct categories, frauds and non-frauds. In this example, the frauds are considered as positive category. Suppose you're building a loan default model. Here, you'll have 2 categories, defaulters and non-defaulters. So defaulters can be assigned the positive category, non-defaulters can be assigned as the negative category. If you are a medical researcher and you're trying to find out whether a person is infected with COVID or any other disease, those people who are infected can be called as the positive category, and the harmless people or the healthy people can be called as the negative people. Just as a simple thumb rule, when you look at the innocent people, they're really harmless. So I'm not really interested in identifying their characteristics. I'm typically interested in identifying the characteristics of criminal behavior. What makes a person a criminal? Why are they so deviant? And that's the reason why I'm going to call them as positive category. Now here, once you are very, very clear as to which of the 2 categories is positive and which of the 2 categories is negative, you can assign certain labels to these 4 numbers. Let's firstly look at the number 4. Look at the row. These 4 people are actually criminals. The row says actual and he's a criminal. The column, when you look, has said that it is predicted as a criminal. When the row matches the column, it is the correct classification. So here you can call these 4 people as true positives. I repeat, these 4 people can be called as true positives. When I say true positive, there are 2 words, true and positive. The adjective true here simply means that the model has got it right. He is actually a criminal and my model is also, or rather the judge in this example, the judge has actually predicted him as a criminal. So this is an example of true positive. Let's look at the number 2 here. Let's examine the row. Actually, the person is a criminal. His actual category is that he is positive. The predicted category is that he is negative. So this would be a case of false negative. I repeat, this is a case of false negative. The adjective false here means that the model has got it wrong. The model is falsely indicating a criminal as an innocent person, and therefore we'd like to call them as false negatives. Now, let's understand how do we label one. There's one person who's actually an innocent person, and the model has predicted, or rather the judge has predicted this person as a criminal. So the actual category does not match the predicted category. So we are going to call this particular case as false positive. Why false positive? Simply because the judge has got it wrong. He's an innocent person, but the judge has called him as a criminal. Let's now look at the last number, namely 3. Please look at the row here. His actual category is that he is innocent. So they are actually innocent, but the judge has classified this person as innocent as well. In fact, this is right. There are 3 people who are actually innocent, and the judge has got it absolutely right. The judge is also calling these 3 innocent people as innocent people. So when the actual matches the predicted, we can call this as true negative. What we have done at this stage is we have been able to label each of the 4 numbers in the confusion matrix. So this is the confusion matrix, and we have tried to resolve the confusion by labeling each of the 4 numbers: true positive, false negative, false positive, and true negative. Let me go ahead and quickly label each of them. True positives, the count is 4. False negative, in this case, the count is 3. Next, what I have is false positive. The count in this case is 1. And lastly, what I have is true negative. Here, the count is 3. True positive is 4. False negative would be 2. I've got this wrong. False positive would be 1. And true negative in this case would be 3. Now, once you get these 4 numbers, it's pretty simple to get the sample size in this matrix. The sample size would be simply the sum of the 4 numbers. So when you take the sum of these 4 numbers, you get this as 10. So we have reached one small milestone wherein we have been able to label each of these numbers and pull out the sample size. These 4 elements becomes the ingredient to calculate what is called as precision, recall, and the accuracy metric. Not to forget the F1 score as well. Let's begin by calculating a very, very important model performance index. The first of this is what is called as precision. Now, if you recall the formula for precision, precision is simply true positives divided by true positives plus false positives. It is simply TP divided by TP plus FP. If you want to identify the precision in this case, all that you need to do is you need to find the ratio of true positives to that of the sum of true positives and false positives. Let's go ahead and quickly identify what is the precision of this particular model. The true positives would be 4 divided by, I have to take the sum of true positives and false positives. So it will be 4 plus FP would be 1. I'm getting a value of 0.8. I can convert this into percentage. I'll get 80% as the precision of the judge. So the judge is precise to the extent of 80%. There's another interesting metric which is called as recall. Recall is the same when it comes to the formula. More or less it's the same, but there is a slight difference. It is true positives divided by true positives plus false negative. So this is how you can calculate recall. It is the ratio of true positives to that of the sum of true positives and false negatives. Let's look at how do we calculate the recall for this particular confusion matrix. In the numerator, I've got true positives, which is 4. I can simply divide this by the sum of true positives and false negatives. When it comes to false negatives, it is 2. Let me close the parenthesis and hit enter. So you're getting a number of 66%. Let me convert this into percentage. Roughly, you can say the recall for this model is 67%. We have calculated 2 very, very important model performance indices for classification models, the precision and the recall. There's another interesting metric which is called as the F1 score. How do we calculate the F1 score? F1 score, if you recall, is simply the harmonic mean of precision and recall. I repeat, F1 score is simply the harmonic mean of the precision value and the recall value. To calculate the F1 score, we can use a simple formula: 2 times precision multiplied by recall divided by the sum of precision and recall. This is what we need to do. I can simply take the multiple of precision and recall. 2 times precision multiplied by recall. This will be part of the numerator. And as far as the denominator is concerned, I'll have to add up the value of precision and recall. So as you can see, the precision value that we are getting is 0.72. This can be easily converted to percentage. So we have obtained the third important model performance index, namely the F1 score. Precision, recall, and F1, these 3 are very, very important measures. And usually these questions, they appear as questions in the interview. So if you're facing an interview, you might get this question as to what's the difference between precision and recall. When do you actually use precision? When do you actually use recall? What are the advantages and disadvantages of each of these? Let me go ahead and calculate the last of the metric, which is called as accuracy. Accuracy is pretty easy to define. How do you evaluate accuracy? In the confusion matrix, when you look at the diagonal elements, let me highlight it for you. These are the diagonal elements. The diagonal elements always represent the correct classification. So what we need to do is, accuracy is computed as TP plus TN. These 2 values will be in the numerator. And in the denominator, you can simply use the sample size. The true positives that I'm getting here would be 4. And the true negative value would be 3. Let me use a parenthesis. I'll have to divide this by the sample size of 10. So TP plus TN divided by the overall sample size. So this will give me 0.7. When I convert this into a percentage, I will be getting 70%. So this is how you can compute the accuracy measure, the precision, recall, and finally the F1 score. Just a heads up here, we do not use accuracy when the data is unbalanced. When the data is imbalanced, many times it becomes difficult to trust the accuracy measure, and hence it is better that we look at either the precision, recall, or the F1 score. One question that usually comes to mind is, when exactly should we use the F1 score? When should we use the precision, and when should we use the recall? But even before I proceed to explain when do we use each of these metrics, I hope this part is very, very clear as to what are the key elements of a confusion matrix. How do we call a particular, what is the justification for calling a particular category as positive and a particular category as negative? Once you call a particular category as positive and negative, you can pull out these 4 metrics and then derive the sample size, which is simply a sum of all the 4 numbers that are present in the confusion matrix. You can use the formula here, precision equals true positive divided by true positives plus false positive. I'd like to draw your attention to the false positive, which is present in the denominator. Ideally, for any model, the precision value should be close to 1. The precision is a value which lies between 0 and 1. If the precision is close to 1, it indicates that the performance of the model is good. The same argument may be made even for recall. If the recall value is close to 1, you can go ahead and claim that the model that you've built is good. And for the F1 score, again, you can say that if the F1 score is greater than 0.9, typically the F1 score is good. The same holds good for accuracy as well. There's a very interesting relationship between precision and false positives. False positives is in the denominator. If the false positives in the data set is less, which means that the denominator is less, and hence the overall value of precision would go up. There's an inverse relationship between precision and false positive. Lower the false positives, higher the precision. Higher the false positives, lower is the precision. It's almost as if we are penalizing a model for having high false positives. If in any model, any classification model, it could be a logistic regression, support vector machine, or a neural network model, if the number of false positives is on the higher side, it will drag the precision value to the lower side. Now, when you look at recall, here we are interested in false negatives. And as you can clearly see, the false negatives is in the denominator. There's again an inverse relationship between recall and false negatives. If the false negatives go up, the recall goes down. And on the other hand, if the false negatives go down, the recall value goes up. I've already explained that F1 score is simply the harmonic mean between precision and recall. How do we actually interpret the precision score? How do we actually interpret the precision score? When you talk about precision score of 80%, it means that out of the total predicted positives by the judge in this case, 80 of them are correct, right? Out of the total predicted number of criminals, 80 out of 100 times the judge has got it right. So in the denominator, you're actually looking at the total number of predicted criminals or the total predicted positive cases. So precision is exactly that. How precise is the prediction? Precision is essentially a measure of the quality of your prediction. Let's now look at the recall value. When you look at the recall value, how do we interpret the recall value? Out of the actual number of criminals, how many has the judge got right? The answer is 67%. So out of 100, let's say there are 100 criminals, the judge is able to correctly predict 67 of them as criminals. So this is how we can differentiate precision and recall. Next, we'll look at what exactly is the difference between precision and recall, and when do we actually look at the F1 score. Here, I've just taken a hypothetical example. You can see here there are 4 columns. We are going to study when do we look at the F1 score. We have serial number, the KPIs. Let's assume that we are comparing the performance between 2 models, namely logistic regression model and a support vector machine. For the purpose of this discussion, let's assume that the precision that you obtained for logistic regression is 78%, and the precision value for support vector machine is 65%. Clearly, logistic regression is outperforming the support vector machine because the precision value of 78% is higher as compared to the support vector machine. So when it comes to precision, you'd go with logistic regression model. Now, let's look at the second row wherein we are talking about the recall value. When you look at the recall value, the performance of logistic regression is 83%. We have obtained a recall value of 83%. But for support vector machine, it is 91%. This is just a hypothetical example to answer a simple question: when do we actually go by F1 score? So in the second row, clearly, support vector machine is outperforming the logistic regression model. So here we have a very interesting contradiction, wherein when it comes to precision, logistic regression model is better. However, when it comes to recall, support vector machine is better. How do we choose between these two models? The easy answer would be, depends upon the researcher. Are you looking at the precision measure or are you looking at recall? If you're looking at precision, you can go ahead and build a logistic regression model and implement a logistic regression model. On the other hand, if you are more concerned about recall, then clearly support vector machine would be your choice. What happens when you do not have a clear choice between precision and recall? This is when you can compute the third measure, namely F1 score. What is F1 score? Just to recall the discussion about F1 score, it is simply the harmonic mean between precision and recall. In this example, the F1 score for logistic regression is 80%, and for support vector machine, the F1 score is 76%. 80% is clearly greater than 76%, and therefore, based on the F1 score, you can go ahead and implement the logistic regression model. So this is one application of F1 score. Typically, we use F1 score when there is class imbalance issue, when one of the two categories is underrepresented or is in a minority, in a hopeless minority, and the other category is in a large majority as far as the distribution of the dependent variable is concerned. That's when you can go ahead and use the F1 score. I'd like to talk about the application of precision and recall. What are the typical areas when people prefer a high precision score, and when do we actually prefer a high recall score? Let's begin by talking about precision. Typically, we prefer a high precision score in the field of medical diagnosis or credit card fraud detection, or for that matter, even when it comes to spam filtering. For any of these three areas, we use a high precision score. Let me talk about medical diagnosis. Example, if you are a cancer specialist, this is just a cooked up example. In case you're a cancer specialist, ideally, you want models that can identify all cancerous lesions without any false positive results. Hence, we prefer high precision score in most medical diagnosis. Let's now talk about a typical credit card fraud detection. In the case of credit card fraud detection, classification models are evaluated using the precision score to determine how many positive samples were correctly classified by the model. I repeat, in the case of credit card fraud detection, classification models are evaluated using the precision score to determine how many positive samples were correctly classified by the model. You would not like to have a high number of false positives, or else you might end up blocking many credit cards, and hence this action of yours would trigger a lot of frustration with the end users. Under these circumstances, you definitely want a high precision score. There are some cases wherein you would prefer a high recall score? What are these areas wherein you look at recall as a measure? Typically, when you're talking about sentiment analysis or Twitter classification, again, medical diagnosis, in manufacturing systems, and lastly, you might want a high recall score again in credit card fraud detection. Let me now talk about why do we need a high recall score in the case of credit card fraud detection. In the case of credit card fraud detection, you want a high recall score of the predictive models predicting fraud transactions. Why? Because a lower recall score would mean a higher false negative. I repeat, a lower recall score would mean a higher false negative, which would mean greater fraud and hence lost the business in terms of upset users. So this is the reason as to why in the case of credit card fraud detection, you would need a high recall score. Now, there are instances wherein you need a high precision as well as a high recall score. Some of these, as I've already mentioned, would be medical diagnosis as well as credit card fraud detection. But the choice between precision and recall is essentially based on the domain that you're working on and what is the objective behind the research. To summarize the discussion that we had, we began by looking at a simple example wherein we were trying to assess the performance of a judge. In this entire example, if instead of the judge, you can just replace a classification model like a logistic regression model or a decision tree or a random forest or a cart model, or for that matter, even a support vector machine, instead of a judge, the same principles would work just fine. So we began with a hypothetical example. We were trying to understand what exactly is a confusion matrix. Once you have the actual and the predicted, you can go ahead and construct a confusion matrix. Here, we need to be clear as to what category are we calling as the positive category and what category is called as the negative category. Once you have made up your mind as to which one is the positive category and which one is the negative category, most of these numbers would follow from that. Remember, the relevant group, the group which is of interest to you, is the group which we are calling as positive. Here, we have to be very, very clear in identifying who are, the count of true positives, the count of false negatives, false positives, and true negatives. Once we have these four numbers, it's very easy to pull out precision, recall, F1 score. Remember, accuracy is a good metric at an overall level, but it has its own weaknesses. We don't use accuracy as a measure typically when the data suffers from class imbalance issue. A high value of precision or recall or F1 score is preferable. Typically, you can take a cutoff of 0.7. If the precision, recall, or F1 score, or even for that matter, the accuracy is greater than 0.7, it indicates a good model. Nextly, we try to answer a simple question: when exactly do we use the F1 score? The F1 score is preferred to that of the accuracy measure when there is class imbalance. Secondly, we can use F1 score when you have two models. In one of the cases, the first model performs better. In the second case, the second model might perform better. Here, we can compute the F1 score, and whichever model gives us a better F1 score, we can go ahead and call that as the champion model and implement it in a real time. Finally, we were able to see some of the applications of precision and recall. With this, I have come to the end of today's video. I request you to subscribe to my channel, also like and share my videos. I thank you very much for watching this particular video. Have a great day ahead.